Okay. Hello, my name is Jared Vieira. Today I'm going to be giving a presentation of a critical review of a research conducted on creating a 3D prosthetic arm using CT scanning. So just to kind of go over what's going to be covered in this presentation, I'm going to give a brief explanation over the introduction as well as motivation over this research, as well as the concept and design, software, and results. So according to the World Health Organization, 0.5% of the population are in need of prosthetics, and they expect to see that number actually grow in the later of the years. And what a lot of people try to do to mitigate the usage of high costing prosthetics, because that's the one major issue is why a lot of people don't use them, is deciding to use a concept called fused deposition manufacturing. This is basically using lower costing materials that are able to operate the same type of function as higher costing materials. So for in which is going to be in my case for my research is 3D printing and a few other things as well. Now with this new method that's being used in the field of prosthetics, they're normally overall ranging from $4,000 to $50,000. This can pertain to certain items or aspects that are used in these type of prosthetics, but the main goal is to overall find the cheapest option that is available in order to be able to get that exact motion for arms movements. So in this case, for this research, is they are wanting to develop a prosthetic arm that is able to be made without the physical presence of a participant and being able to develop a mirrored arm. And how they do that is through CT scanning. So what they do is they have a participant take a two CT scans. What they do is they take the CT scan of the amputated arm and then one of the opposite arm that is there. And the reason why they do this is because they're planning to make a mirrored arm, basically taking the CT scan of the arm that they have and creating a 3D model of a mirror of that. So we could have that being already something that's available and not needing to be created by hand or requiring their in presence for measurements. So what they do is after they take the CT scans, they turn them into a digital imaging and communications and health format or DICOM, and they upload it to a software that is being listed here on the pictures, so on A, B, and C. And it basically shows the geometrical aspects of the arms, including the specific placements of where their bones are and measurements as well. And the reason why they're doing this is because they want to make sure that as they're overlapping the arm, they want to make sure that it's exactly where it's supposed to be in position and it's not going to cause any discomfort for the person. So they're taking into consideration both the arm and as well as the socket for the amputee. And the software that they're using is a digital mimic suite. So this is to show, as I mentioned, the geometric aspects of the arms, as well as showing the exact positioning of where the anatomy is of the arm. So after they do that, they also transfer it over to a 3D modeling software called 3matic, which is kind of almost like Inventor, but in this case, which I believe is a very different method than most would normally do, is instead of 3D printing strictly an arm, what they do is actually they 3D print a mold. So they take that CT scan and they create it in 2D format and create a mold over it so they can actually use silicone plastic and make that arm rather than 3D printing individual pieces and creating an overall arm together. This will, in my opinion, shorten time and speed up the process rather faster than normal options. So the from A to C is a little more of a 3D images that were obtained from the Mimic suite from the previous slide, and then from E to H is the 3D models that were obtained using 3Matic. So this is a block diagram, basically giving a summary of what I had just mentioned about how the process undergoes. For the prosthetic arm, you have the CT scans that were obtained from the participant. They then go to Mimic's Innovation Suite to analyze the geometrical aspects of the arms to make sure no overlapping happens. And then they get transferred to 3Matic to where they can be used to develop a silicone mold. And then they're going to undergo a process called DSC, which I will explain shortly. So this is the final product. What they have here, what they have here is the arm as well as the patient on A. And what they do is they show overall the two main areas of interest that they had, which was the arm itself as well as the socket. Now, the reason why the socket is actually very important is because it's going to be placed to where the stump of the arm is. And we want, particularly for patients, to be able to have a comfortable prosthetic. Otherwise, they're not going to be able to use it and it's going to be feeling weird. And the one thing that we want is to be able to have a socket that's going to comfortably fit them and also not prohibit any certain types of motion. So we can see from images from C, D to E of what the mirrored arm looks like, as well as how it looks naturally when both arms are extended out. Now, after obtaining this, the one thing that the main goal that the research were trying to do was seeing how exactly accurate this type of method is. And in order to do that, they had to use a certain calculation, which is the DSC that I was talking about earlier. That stands for dice similarity coefficient. Now, what this is an equation that takes in consideration two volumes, the volume of the participant's original arm, as well as the designed arm that was made using the softwares mentioned before. Now, from the results gathered from this research, they found that the prosthetic arm had a 96% overlap between the two arms with only a 0.67% error, meaning that the arm that they generated was very, very accurate. And they also found that the socket was 95% with only a 2.97% error, which is relatively a little bit higher, but it's still in a good zone and range of what it should be as of right now. And of course, could be improved further on with more alterations in the 3D modeling. So in conclusion, this research had used a successful usage of CT scanning in order to obtain a prosthetic arm. And they used a very interesting software, Mimic's Innovation Suite, that can take those images and be able to analyze them autonomically, as well as being able to transfer them to a 3D software, which is quite a difficult process, but is done with ease. And one thing that I would like, or in my opinion, I would say could be for an improvement, is to use 3D scanning rather than CT scanning, primarily because CT scanning can have certain risks, specifically cancer for a participant. And the one thing that, as researchers, we do not want to jeopardize the health of our participants. So I believe that 3D scanning is something that should be utilized more because it's safer to use. And the main reason why they decided to use CT scanning is something that was available to them at the time. And I believe that's something that 3D scanning could be used. And I know that a lot of people believe that it can't be used because it requires such high cost machinery. But I personally have used mobile 3D scans, and they work just as well as good in that case into transferring scans into a 3D modeling software. And I believe that's also another great alternative to do as well. So this is the cover page of the research article, or research journal, pardon me. And that is it. Thank you so much.